Hello and welcome everyone and welcome back to the channel. So in this video, I want to show you what is on my AI server right now. There have been a lot of questions that what do I actually use my AI server for? And I use it for inferencing. My primary use case is inferencing and that's it. Anything else that I do is for fun, So when I say inferencing, why do I need to invest so much into inferencing server? This server is quite beefy. It has 512 gigs of DDR5 RAM, two NVIDIA 6000 Pro CPU that is very powerful, W9 Intel Xeon CPU, 56 cores, 112 threads, and enough power to support all of that. But what do I do with such a inferencing server? And this is what I wanted to show you today. So let me take you to my actual Jarvis inferencing server. And you can see that currently it is processing and executing some requests over here. And there is one request with the generation throughput of 87 tokens per second. Another request, a post request that came in over here with 6,000 tokens per second of the prompt processing, and the generation is also moving over here. So how do I use so much of compute? There are some AI agents that work for me. Even while I am not working over here, those AI agents are almost always working. And before I move to show you what those AI agents are working, let me show you a light LLM dashboard that I have. We can enter and just take a look at what is the quantity of requests that I send to this server. So you can see there was a couple of days that I did not use it as much. I only had like 5 million tokens input and output, right? But on the days when I did, it is 78 million tokens right there. And this is today, and we are having about 29-30 million tokens over there. Keep in mind that this is only my light LLM server. This is not counting the GLM 4.7 plan that I have, the coding plan that I have. So what do I do? Why am I having so much of requests and response back from this light LLM server, which is just interfacing my vLLM? Before actually I go over there, I want to quick show you that what all models do I have configured over here. So one of the models that I overly use is this Jarvis Thinker model. And behind this Jarvis Thinker model, we have Minimax M2.1. It is an absolute joy to run. And this is my Minimax startup command. And you can see that I am using Tensor parallel size of 2, which means I'm using both of my GPUs over here in order to get the maximum benefits. And I can get up to 192K of context length over here. And this is pretty cool. 192K of context is the max that this model supports. And in terms of quantization, if you'll see, this is FP8 int 4 mixed quantization. This is such a cool model. So let me go to Hugging Face and I'll show you which exact model this is. This is an absolute best of the model. And you can see that this is kind of targeting the system that I have, 192 gigs of VRAM. So two NVIDIA RTX 6000 Pros perfectly are meant for this. That this is a mixed precision model where self-attention weights are copied directly from the official version. And if you guys do not know, Minimax M2.1 was released as an FP8 full precision. Its self-attention weights are at FP8 and only the expert weights are quantized using AWQ W4 A16 G32 schemes, right? So 4-bit weights, 16-bit activation scaling factor per group of 32 weights. I am currently running this particular model as my primary inferencing model. We are having FP8 int 4 AWQ model from this guy. Trust remote code is that, so like if there are some configuration minimax m2.py, if trust remote code is on, then the Python files in this remote repository can be trusted, and then you can run those things. Okay, let's keep going. Surf model name Jarvis Thinker, and this is very important because this is now being served using vLLM. Let's say In future, I want to switch my model from Minimax M2.1 to, let's say, Prime Intellect, right? Or any other model, GPT OS has 120 billion. If I want to switch that, then I do not have to actually change any configurations in my end applications. I just serve the model as Jarvis Thinker. And all of my applications that are utilizing the model name as Jarvis Thinker automatically pick that up. Now, GPU memory utilization is set to 0.93. And what that does is, let me show you this over here. My memory utilization is at 0.93. Max num sequence is set to 48. That gives me a very good ratio of speed that I want. My host is 0000, so I can make requests externally. The internal port is 8000, but that don't really matter at all because I'm mapping this internal port 8000 to 10002 as an external port. Enable auto tool choice. This is required if you're using what I'll show you next. When you're making these calls from these AI agents, then you want to make sure that your tool choice is auto and you're not forcing a tool choice every time. So auto tool choice over here, tool called Parser is Minimax M2. And this depends whether you are using Minimax or let's say DeepSeek or GLM 4.5. Tool called Parser is required because the tools have their own structure and they have their own format for different models. These models now provide a tool called Parser that can be embedded in vLLM server. Then we have reasoning parser, exact same logic over here. So there are two reasoning parsers. There is a reasoning parser of Minimax M2, and then there is a reasoning parser of Minimax M2 underscore append think, I think it is called. And if you append think, it adds the think tags at the start of the reasoning. Whereas if you do the reasoning parser of Minimax M2 and not the append think, the reasoning still happens. But instead of appending the think to the response, the chat response, it appends in a different attribute in your Python SDK or in the REST API call. So these are the most important attributes that you need to set for AI agentic call. One thing to note is that the number of attention heads have to be divisible by the tensor parallel size. So let's say if you have 3 GPUs and your number of attention heads, and I'm making it up right now, is 16, then it won't work. If your attention heads are 16, then you will need either 2, 4, 8, tensor parallel size for it to work. So just one confusion that people normally have is that whether this needs to be an even number or whether this needs to be a very specific number. It just needs to be a number your attention heads are divisible by. Almost always in every circumstance, number of attention heads are divisible by 2. All right. So I've now set up my machine. I have my vLLM server up. It is almost doing some requests and responses all the time. What is it actually doing? Now let's come to the step number 2 of what it is actually doing. So it is actually right now, and if you see, I am using something called open code over here, and you guys must be familiar with at least Claude code that has become very popular in the development community, and open code as well. I want to believe that most of us have heard about Claude code and open code. And I did not used to like these or such AI agents because I used to code everything by myself. And when I say myself, I would still use AI. I would take help of AI. But most of the guidance that I would want to pass on would be mine. But now what I do is I actually write the architecture. I still brainstorm the architecture with AI, but I write the architecture, I brainstorm things with it, and I make sure that it is thinking in the right way. So as you can see on this screen right now, we have open code. And this open code has been working on doing something from past 20-25 minutes for me. And I get a ton of emails that are junk emails. And I'm trying to build a software for my personal use case, which can go read my emails, analyze whether that particular email is good or not. Because many times emails pass the spam filter, and I'm at my 96% Gmail limit. I am building AI enabled agent that can go in, analyze my email, and I have given it enough context about what I actually want and what I don't. And based on that context, it will review whether I would wanna delete the email or not. Google's AI may or may not flag it as an email that I want to keep or not based on the rules that I built for it. Once this is done, this whole agent coded application is done, but I'll still have to review it. I mean, it could be very well a big AI slop. So I don't want to just release something that is an AI slop. But once it is done coding this whole thing, so it goes through an AI council after I'm done building an AI slop created from open code, which actually provides way deeper insights. It does the whole code review of the process, and there are 4 members of the AI council. They sit together virtually, they do the code review, and they, from the security perspective, from the architecture perspective, and then there is a bigger guy, Jarvis, sitting on the top, who does the review. Finally, they vote on each other's topics, they debate, and then they finally come out as who is the winner. And I was so happy that I built that. The council, and I think I got the idea from Karpathi's tweet the other day. I incorporated that thought process into my PR review. I can create an AI slop, and then the AI slop can be reviewed, in the end. Okay, but let me show you. I was actually waiting for compaction to happen. So I have set the maxed context for this particular open code as 160K. So when it reaches a certain percentage value of the context, it compacts the conversation, and then it continues going at it. And if you see, there is a special agent over here. This is called Sisyphus. This comes from something called Oh-My-OpenCode, which is pretty cool. Let me show you that over here. So Oh-My-OpenCode has gained a ton of popularity recently, and you can see 13.6K stars over here. It gives you this Sisyphus agent. I highly recommend you to go and just install this particular Oh-My-OpenCode. Yes, you may want to tweak some of the settings here and there, but at a very higher level, this is really, really good. So what I've done is I've installed Oh-My-OpenCode on my system, of course. I've also installed couple other MCP servers over here. So Brave Search, the freeware version of it. Context 7 is free, so I've installed that as well. Combination of Brave Search and CRXNG local works for me perfectly. And let me show you what sequential thinking. Opening a new instance of OpenCode, and let me ask it that can you use sequential thinking to tell me what is the best way to go from Minnesota to Michigan, right? So let's see. It is now using the sequential thinking process over here. Invalid tool. All right, so maybe I'll have to see something that happened over here. Tool sequential thinking error. Model tried to call unavailable tool. And these are the list of available tools. So sequential thinking is right here. And then it was able to use sequential thinking. Okay, all right. So it kind of got confused because it wanted to use the tool exactly like this, sequential thinking, but it was supposed to use sequential thinking underscore sequential thinking over here, which is what it found after reading its own output. And this is why these AI agents are pretty cool, because you do not have to correct them. They read the error messages, they self-correct themselves, and in the next response, they are able to fix that issue that they encountered in their own thought process, right? So this is like a interleaved thinking at its best. Okay, so it thought through and it is thinking and thinking, and then it is saying that, hey, flying is 1.5 hours, which is best. And driving is 10 to 11 hours, which is best for flexibility, comfort, and having a car at your destination. Take I-94 through Wisconsin. This was pretty cool. So I think it did utilize some kind of search, if I'm not wrong. Did it? Did it not? I don't think so. So it looks like it just told me all of this information from its trained memory, which is really, really awesome because this is factually true. It does indeed take exactly this much amount of time and exactly this much amount of time too, because I've taken both of these routes. I'm really impressed by Minimax M2.1 model. Okay, and then we also have LSP support over here. For example, changing these Python files over here, cli.py, graph.py, graphstate.py, and nodes.py. So it is making changes to some files and it is listing them down over here. And you will see that there is a LSP Pyrite installed over here, right? So there's a Python's LSP language server protocol that got activated while dynamically Python files were being modified and tested. In your IDE, when you hover over any method, and then you see the tooltip kind of thing, so you see the details that come out of it, or when you control click on that particular method, you go deeper in, right? So all that intelligence, that information, the build of the whole end-to-end tree structure of your code, that is provided by an LSP. Oh-My-OpenCode has LSP support, and very recently Claude added LSP support in their own workflows. And this Sisyphus agent is really, really awesome because it keeps track of the to-do list. And if there is any particular action item remaining, you do not have to stop. It won't ask for your confirmations. It will go ahead and go to the next step, and it will perform the next to-do over there. So I can be rest assured that I'll go to bed, I'll sleep, this will go finish the task that was assigned to it. Which brings me to my next thought. Why do I have such AI server at home? Especially for this one reason, because I can analyze my personal emails without having to send my information to any external provider. So OpenAI doesn't get my data. No one gets my data. And this is completely personal information that I have. If I need to build something enterprise-wide, I do not need to send that information, all the code that I'm building. No one else knows about it. And I am the only one who built that code. And when I say I'm including my AI partner, Jarvis, over here. So I'm the one who built that code in cahoots with my AI partner, but all of that stays local. And I am a software architect. Day in, day out, my job is software. And anything that I use has a lot of scrutiny. So I want to customize every single aspect of my AI server, including privacy of the requests, the speed that I get from my AI server, that is insane. I can get up to 250 or 290 tokens per second for Minimax. And some other higher, some smaller models have been yielding up to 700 tokens per second when I throw parallel requests at it. I haven't done a lot of performance comparison over there in that aspect though, because I not normally do more than 4 to 5 parallel requests. I do a ton of sequential requests though. So that is at a very high level what is on my AI server. What else do I do? Sometimes I do image generation and video generation, and only for fun. All right, so that is all about it. Why do I use my AI server as an inferencing server? It's because I just enjoy having a local AI that works fast. And given that my use case is coding, I need to have a coding assistant with me 24/7 working for me all the time. That's it. That is it. For most people, this is definitely a very expensive setup that they probably don't need if they're not using it. For me, it is a necessity now because I am using it. I'm using it as a junior developer. I'm using it as an architect who designs the systems and then gives the documents to my junior developer, has an AI council that reviews it, comes back with answers to me, and I can review it, and I can then make a decision whether this whole thing is approved or not. Having such an AI, such a power for a junior developer may or may not make him lazy. But having such a power for a software architect is lethal. I will leave it over there. If you like this video, please like and subscribe. My target for this year, I know it is a very ambitious target, is to reach 10,000 subscribers. Very ambitious target. So let's see if we can do that. But I will see you guys in the next one.